Hey everyone, thank you so much for joining our LinkedIn live session. I'm here with Brian Barnier. We're going to talk today about answering business questions with data analytics, and we're both super excited to go live. So Brian Barnier is the Director, Head of Analytics at Value Bridge Advisors and Burnt Oak Capital in the UK. He also teaches a graduate course in data analytics at the Colin Powell School at City College. So Brian, thank you so much for joining me here. Super excited to talk to you about, how do we answer business questions with data analytics. So how about you tell us a little bit about yourself?
Yeah, so I use data analytics in a variety of ways to grow companies, grow investment funds, and occasionally grow countries. And it all comes down to a mix of my background of statistics, systems analysis, which is a big thing we can talk about today, technology, of course, that makes it happen, and then strategy in a business sense, which is why we're going to talk about how you can connect data analytics to answer business questions.
Great. Well, I sure have a lot of questions for you today, but if anybody is joining us live, please feel free to ask Brian or myself any questions that you have, and we'll do our best to answer as many of those as possible during the session. So I think before we get into it, really, the first question I'll ask is, can you just give a broad definition of what is data analytics and kind of what it encompasses?
That's a great question, Kate, because the thing about it is it's such an elastic term that it's come to take on a whole variety of different meanings. The practical thing that people need to know is there's sort of this recent phenomenon of data analytics that's really built around machine learning in particular, but it's a mix of computational math to make those algorithms more efficient so they can run on your phone, and then software engineering, which is why we talk about things like we need requirements, and here's results, and we throw the results over in response to requirements.
Right.
Now that's different than all these other flavors of data analytics that have been out there in market research and in logistics and in operations management and in emergency management and in sports, right? I mean, like books like Moneyball, Bill James, all these things have been out there for decades because most of this came in the sort of the early 20th century industrialization between World War I and World War II.
Right.
And that's this thing where a lot of today's data analytics people don't know that exists, which is why they've got the gap.
Got it. And we do already have a question, actually.
Wow, all right.
A minute into our conversation.
Wow.
Yes, Dinesh Saini here asks, how can I start a career in data science?
In data science, huh? So
Yes.
we're going to talk about something even cooler than data science today. We're going to talk about decision science, Dinesh, because we want to be able to understand how do people make better decisions with data. And decision science has two sort of legs to it. One is the data piece, and that comes out of things like operations and logistics. And if you go into a business school, almost everybody is forced to take a class in decision science. More analytical. There's another piece of it that's more behavioral, that looks how people respond. These can be workers on an assembly line or in a production facility. They can be, today we're talking about the Lion air crash, and then the Ethiopian air crash, and the pilots and the flight attendants, those behavioral issues, how they get involved. And then of course you've got the sort of the classic market research thing and understanding how people respond to new products, like live on LinkedIn.
Right.
So bringing those two together is what's really important. And so when you're saying about how to get started, it's getting started in those two bodies of knowledge and building up both ways, because that's going to then take you to the business decision and having context. We talk about data context, or more syllables, data contextualization, huh? That sounds like a better word, right? In order to make decisions. So that's the starting point. Understand those two historic pieces, how they've worked and how they've driven millions and billions of dollars in revenue over the years. That's what makes you relevant as a data analyst in your company.
Thank you for that. And for those just tuning in live now, here with Brian Barnier talking about answering business questions with data analytics. So if you do have questions on the topic, we'll be happy to answer them live. But one question I had for you, Brian, is how do data analysts and data scientists even know what are the right business questions to answer?
Again, a great one. And there's, it again goes to the historical roots, right?
Right.
Because people in those other disciplines, when they take those other classes, as often juniors in a business school program or engineering, or sometimes even sophomores, they are learning both the business context and the analytics at the same time.
Right.
And when you have somebody that comes in today's data analytics, where they learned, give me SQL, give me some Python, give me some, a little bit of R and then put some sprinkles on top and you got data analytics, right? They never got any of those classes, right? So that's why they're disconnected. So understanding those is about remelding those, bringing them together, making a great looking latte, right? And mixing it all up so that you can bring those two together. And that's the secret of you got to understand the business, understand the business process that you're using, then you're going to understand the challenges, right? That's going to lead to problems to solve. That's going to lead to questions to ask. And then it makes it real obvious what kind of analytics we're going to do.
Right, so you mentioned getting to know the business and knowing which questions to ask. What are some examples of how, somebody who works in data can start working with the business? Do they just set up meetings and say, hey, I'd like to talk to you, or what's some of the best practices there?
A couple great things. First of all is talk to HR and have them stop writing stupid job descriptions.
Right.
Because you've got these stupid descriptions that are talking about a whole stack of software, and then they freeze people in to these jobs or they won't be successful. And you've got to be like our first questioner and force yourself to go out and learn.
Right.
So thing number one is you've got to ask for a mix of skills. Thing number two is then you build teams. So there's product managers here at LinkedIn. I used to be a product manager, launched some very successful products. We had everybody sitting around the table. And we even gave people the opportunity to switch roles from one thing to another to learn a little bit more about some aspect of the business, right? Like somebody who's just doing product dev, next time around, they get to do customer support. So they get to understand that experience, or user experience if it's an intensive consumer application. Or you can be part of a market research team, right? Because now people are building their careers, building skills, and it gets better and better and better over time. So that's another way to cross-pollinate within the team. A third way that you can go about doing it is getting involved in industry associations, right? So if you're in a data group, but you go and join whatever your association is, chemical products, and go to their meetings. But you may be going primarily to sessions for data wonks, but you can go to all the other sessions too. And you can see that the chemicals will explode. You can see that the airplane could crash, right? You can see how people respond to buying women's luxury goods, purses and stuff, right? Then you get that sense, and now you can do some really, really cool things because you're empowered with an understanding of the business. You're empowered with an understanding of data.
Yeah, I agree. I think the rotational programs are really helpful, and I myself definitely benefit from going to these industry organizations, especially when I was in risk management. I would attend every chapter meeting and conference I could get my hands on, because it's just that kind of relaxed level of learning where you're not really trying to learn something, but you learn everything you need to know, and you meet the right people and you have those conversations. So thank you for that. We do have another question from Jagruti Thakar. Is data analytics for everyone or only engineers? And can other professionals build a career in it? What do you think, Brian?
Absolutely, and I'll just punctuate my prior comments by saying this. Right now, I'm missing a call with the U.S. Federal Emergency Management Agency because I apply analytics in that space, and I advise a company called Disaster AI, Disaster Artificial Intelligence.
Okay.
And these are all people, like the CEO of the company is a former naval officer, and there's an ethnographer involved to understand how people respond to emergencies, and all kinds of fascinating people. Right? They've got context, and they're applying machine learning to these problems of how you plan ahead for like shoreline evacuations and how do you respond. That's an example, right? Everybody sitting out there has probably got some webinar, some conference call, some meeting, some activity going on right now that you could be joining, or joining right after this very important live on LinkedIn, right? Because I'm here instead of being there. Then you get that sense. So you build your knowledge base.
Right. Thank you for that, Brian. So, so the next question comes from Tanut Karnwai. How does data science solve business problems when the data is unknown or missing? So that's a difficult one for you. Go for it.
Yes and no, because see, here's the thing. I mean, those of us that have been doing this for years, I mean, they were doing this, decades, half a century before I was even born, right?
Yeah.
And if you go back and look at the math, I mean, the math goes back, 200 or so years to be formalized, and another 200 years to Descartes before that.
Yeah.
So you always had this issue, but here's the thing: when you understand the context of what's going on, you
Right.
understand the business, then you understand, we talk about, being at the coal face, right?
Right.
Somebody that's out there, that's working, that sees the nitty-gritty of the problem.
Yeah.
Then we can sit back and say, what's the question?
Yeah.
And then we can sit back and say, what can we find that helps us answer this question?
So you don't need loads and loads of clean, perfect data to try to start
Right.
addressing questions.
And if you want an example, the best by far book that you can get on innovation is They Made America.
They Made America?
Right, 200 years from the steam engine to the search engine by Harold Evans.
Okay.
It was also made into a PBS series, so if you can't handle reading, you can play the PBS series on your
Who reads
treadmill.
these days? Brian, come on.
And but that really tells the story of people who are truly innovating.
Right.
I mean, we're sitting here in Manhattan, right? They were doing the steamboat up and down the Hudson River. I mean, blocks from us were these amazing innovations. Tesla, died in obscurity 4 blocks from us, right? I mean,
Yeah.
that's the kind of amazing stuff that happened here, and that you can understand how people have been solving this for years with far, far less data.
Right. And I think this question is actually similar but different. So Asa Cox asks, what is the biggest barrier to decisions being made with data? So kind of some of the challenges and barriers with actually making decisions.
Another great question, and I'll put it in 2 categories. One is when you've got a fracture between the business
Right.
and data analytics, just like you're setting up this sort of software engineering kind of framework.
Right.
The other aspect of this comes into play when people are actually working together and they're trying to communicate, but they're having difficulty. So I'll take the second one first. And in those situations where they're trying to communicate, it usually comes down to understanding some nuance and trying to get somebody to articulate something. That's where, Kate, the stuff you do around data storytelling becomes so important. So you can put it in some kind of context.
Right.
So for example, one of the things you talk about is always express it in the notion of a person. Right? A person does this in their journey through their life or their journey through a website. It's much better than sitting back and saying, we did this research, let me fill you with these numbers. Right? So that's one of many techniques that you're really good at in storytelling to overcome that. The first piece that I mentioned really goes back to the questions that have been asked already, which is that you've got to break down these silos of treating data analytics like a software engineering product, and you've got requirements and results going back and forth.
Yeah.
You're just doomed, and that has got to be fixed. And there's a lot of other people that are writing about that too. Andrew Ng in his book on the AI strategist talks about that. So there's a lot out there, but really all it is the old-fashioned business analyst
Right.
on steroids, right? In more of a product management sense. If you want to understand that, what that means, read Merle Crawford, New Product Management. It's not the sense of product management that says, oh, you're an app dev manager, sort of glorified. They put pixie dust on you.
Right.
But a real product manager who understands the customer and the market and what's going on. So those are 2 very clear ways to solve that issue out there.
Okay, great. And Akfat asks, actually, it'll get us a little bit into, I think, data visualization, but how to present the results of complex analysis to non-technical audiences, especially for decision making.
Yeah, so here we think about birthday cakes.
Okay.
And there's sort of
birthday
different
cakes.
layers to birthday cakes.
For those
right?
tuning in, we're talking about birthday cakes and data analytics.
There you go. Or if you're a fan of Shrek, it's parfaits, right? Or maybe onions or something, but it's got layers, right? So the thing that we start with is on the top layer is that storytelling. You've got to personalize it and be able to look at it through the eyes of somebody that's taking a journey, which we've already talked about. The second layer that we come down is we're now pinning that down to how the data informs each decision that somebody's making. If it's user experience on a website, it's which click do they do? Right? Or maybe it's a choice about what options do I order on an automobile? Or what button do I push on the coffee machine in the office? Right? All these are things that can be studied and come back. And again, some of it's informed by data, but this is where you really have to go and partner with the psychologists, the sociologists, the anthropologists, the ethnographers, people who are used to studying behaviors. Right? And at LinkedIn, I'm sure they're using those because what do we have here? This group behavior interaction. And there's people who have been studying this stuff for decades, over a century, going back to the mid-1800s, which can inform your project, especially if you're in the consumer space and you're trying to build flow and momentum and things like that. The third layer of the cake then is being able to take some of this data and think about what visualizations really matter to illustrate what's going on. Too often we get in these tools of all kinds of great things like you're a Tableau expert, but a lot of people aren't as good as you, Kate. So they sit back and they pick just a couple things that are their go-tos.
Right.
and they don't understand. Like tonight in my class at City College, I'm encouraging people, whether using Tableau or Excel or whatever, to use data animations, right? These things, if you've seen like Hans Rosling videos, right? Yeah. You've seen how data goes out in time series, because that's what we're working with tonight, right? That's very powerful because it shows an X, Y, and a time axis, and it shows a behavioral activity. And you can look and you can label highs and lows and twists and turns and tell stories that happened in behavior around that, whether it's the stock market or whether it's acquisition of some new product, or whether it's a change. Like we just looked at the change from cameras going from analog to digital. You can see it in the data, and it comes out and you can explain it. So look beyond some of your go-tos to all these other great things. In my next week's class, we're using data maps to be able to understand how that works. If my students are watching, that's your assignment tonight.
Awesome. Okay, so you mentioned data animations, and I love data visualization and all things data, but are there any barriers to using data animations? Are there particular audiences that you think would kind of stay away from that, or maybe they feel like it's a little bit too advanced? Have you seen anything like that?
Yeah. I mean, there's sort of two categories, and remember, there are like behavioral scientists that study the ability of the brain and the eye to map this stuff. But you don't want to over-ornament them, because you're going to blow people away. And the very issue you're trying to resolve, you're going to create a problem with. So, for example, I tell my students, start with a big data map to show the pattern, but then explode it, right? Bring the axes down, look at the area of interest, things like that to get at, drop out some of the time series and say, hey, this is a thing that we're looking at. Because the ones that are very variable, well, those are going to complicate your chart.
Yeah.
So say, okay, here's the big picture, but now we're going to strip away the ones that are moving with a lot of volatility, and we're going to look at the ones that are on a downtrend, and we're going to look at the ones that are an uptrend, and we'll peel those off.
Yeah.
Right? So we look at those pieces, we talk about why the uptrend and the downtrend, and then we come back and we look at the volatility. So what's causing some of these to move? Is it an artifact, or is it something that we can get our hands around to do something useful with? And that's what becomes very important. Like one of the companies I work with is Blue Sky Capital, and they look at lease rates and assets and financing and stuff like that. And they've got this wonderful cloud analytics platform. Nobody else is like it. But they can pull this stuff apart to help find rate patterns and to help understand what works and doesn't in very complex ways. That saves millions of dollars. But the thing is, they're dealing with really deep business problems. And that goes way back to the beginning. You can't do that unless you really understand the business.
Right.
And you can apply the math, the data, and the visualization techniques to it, which is why to the very first question we had, I think that was Dinesh, great question. That's what you can do if you want to drive forward in what you're making happen.
Okay, so you mentioned Blue Sky Analytics. Is that a software, or what is that?
Blue Sky Capital Strategies, they've got a cloud analytics platform for leasing and asset finance management.
Are there any other platforms or software that people can use for, I know you can use Tableau for some of that animation, but I wanted to hear if you have any other recommendations for tools.
Oh, well, I mean, there are a variety of tools that are out there, and there's, like I just went to a conference, so there's a whole long list, and I don't want to get in trouble looking at one or the other, and you study that market more than I do. But the thing that, just because I teach at City University of New York, and we want to, get a baseline, look at Microsoft Excel, right, which we all have academic licenses to. There are lots of functions in there that most people don't know exists. And when you take it up to Tableau or anything else, click whatever, all of a sudden there's more and more and more, and that's why it's getting past the go-to functions to things that, in the context of that birthday cake, tell the story.
Right.
Right? So why use time series data when you can use a scatter plot and tie the lines together, and that's much more informative, right?
Yep, I agree.
It's like one of the things that people look at, a big myth in economics for anybody that's out there, is that you have to have prices going up to get people to buy more, because there's this thing from hundreds of years ago that you've got to have people with pickaxes digging away, and you've got to pay them more to work with pickaxes.
Yeah.
Well, we all live in a digital world. We're doing this right now, right, on LinkedIn.
Yeah.
And this stuff scales. So cost falls.
Right.
And that's been happening since 1995, which is probably before many of your users were born. Right? So that's the thing. And so hearing this myth, seeing it in textbooks, it just isn't true. And when you do this reveal, whether you're talking about it in a manufacturing production cost context in your software company as a product manager, economic data, whatever it is, or just a consumer math class in high school, showing the real data empowers people to make better decisions in their lives.
Right.
Make sense?
Yep, absolutely. We do have another question from Ronan, who asks, can you talk a little bit about the difference between exploratory and explanatory data analytics?
Great. And it's actually even broader than that, because when people are using those terms, what they're really trying to do is echo back into statistics. And we use statistics in different ways, and there are different categories, so I do not want to get in the way of your textbook. If you've never bought a good business statistics textbook, I will recommend one. And I will recommend this because it's both a great book and because it's out of print, which means it's really inexpensive. But it's Morris Hamburg's Statistics for Business Decision Making. He was a professor at Wharton. The last edition is from the 90s. It's still a great book, and it's very inexpensive. And it's for business decision making. So it's not like a theoretical book that talks about balls and urns and red balls and green balls and a lot of theoretical probability. It's like, how do you stock milk in a store?
Yeah.
Right? So that you maximize sales without having so many go past their use by date. So very fundamental problems like that. And it's a great book to walk through and look at some of the assumptions that are out there. When we look at that field, I'll put a few more categories. There's descriptive statistics, where we sit back and say, what's going on in the data? And then we can sort of inference off of that. Now, exploring is sort of part of the descriptive stuff. We're poking around and finding what's going on, but we're sort of making that formalized. And the explanatory, when people use that term in data analytics, they're trying to bridge those two a little bit more. And some people even try to go into what statisticians call forecasting, and data analytics people are more likely to call predictive. And where we get lost is we don't do the descriptive work. And one thing that Hamburg points out over and over and over again, and my statistics professor pointed out over and over again, is plot the data, plot the data, plot the data, plot the data.
So plot the data?
Plot the data. You got it. Because all these statistics, whether it's a standard deviation or variance or means or everything, hide tremendous variation in the data. And we get in that same problem when we're doing, especially unsupervised machine learning. So you need to understand the data and how it behaves, and that's why at the very outset of this we talked about systems analysis, where systems analysis becomes so very, very important. Folks, this is the stuff that's used to get your package delivered to you, or that's used in your driving app, or airplane routing, or a gazillion things are all about systems analysts. Even the network bandwidth optimization for this live on LinkedIn you're watching now is all run through systems analysis math. That's what you want to use to understand cause. Because when you've got cause, you've got power as a data analyst to explain things in a meaningful way, in a causal way, not with correlations. And remember, machine learning is about correlations. It's not about causes.
Wait, so correlation is not causation, Brian? Say
Shocking!
it so.
Shocking!
All right, moving on to Madura's question. Since data cleaning is considered as the most important aspect of data science or data analytics, can you tell me which are the tools that industry companies use on a large scale? So it is said that data cleaning takes about 80% of a data scientist's time on average. So it's a good question, Madura.
Yeah, I mean, I'm not going to go into sort of a list of product endorsements
here.
Because again, I just came from the conference and I followed up with every single vendor at the conference because I said, look, all I want to know is what your new cool feature is. And there's a number of them that are out there. For example, there are some of them that are actually using a little bit of machine learning to go look at the layout of a column and be able to say, what do we think this column is, and give you suggestions for it so that you can mix and match columns together and find index keys and things like that.
Okay.
And so that's kind of cool that's out there. There's others that allow you to take in data from different sources, right? Some that's coming in from some vendor on PDFs and all kinds of different file formats and standardize the formats. That's very helpful to do. And then another piece of it that is useful is trying to go through and sort of do the mix and match to pull out your outliers and duplicates, and then think about whether it's relevant to have those or not, and give you choices. If you want to, then the analyst is going to run the piece both ways to find out what happens. Right? Because again, when we plot the data, we find out that outliers can become really, really important to study outliers. Right? Whereas so many things that are these sophisticated filters, right?
You shouldn't just remove all outliers. Is that what you're saying?
Another shocking insight here. Wow, Kate, you are just so amazing. You know, but I was at a conference 10 days ago here in Manhattan where I kept hearing filter, 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 filter. I'm going, how do you know signal to noise, right?
Yeah, right.
How do you know what that's telling you when you're throwing it out, right? How do you know that that's not giving you cause, it's pointing you to a new direction?
Exactly.
Right? And so these are the kinds of things that become difficult. So when I think about data science or decision science, I really focus on that understanding of the data piece. And that when people are doing data work up front, they need to, just like the data decision type people, they need to understand how this is going to be used.
Right.
Right? So they don't throw on one of these little click box filter assumptions.
Yeah.
That gets you into a lot of trouble later on. So I just got to caution over and over and over again, understand the tools you're using, plot your data, see what's happening. Because so many times when I go in, that's a lot of what I do. I fix problems in machine learning and data analytics. And so often when people are wrong, we go back to the data and we find out, oh, well, somebody told me to click this thing to filter this thing and whatever the thing, and it was supposed to be a really great
And it's so easy to do, right?
Right.
To just filter something out.
Right.
All right, before we go to the next question, we had a couple of people ask again, what was the name of the book that you recommended? So if you can just repeat that, please. The most recent, I know you mentioned a lot of books, but I think it was about the most recent one where the practical examples that don't talk about different color balls, but talk about milk, stocking milk and all that. Yeah.
Morris Hamburg, MorrisHamburg. He was a Wharton professor.
Okay.
And later editions, he had a co-author. It was one from the U.S. Department of Transportation. And it's, I think, Statistics for Business Decision Making.
Okay. Got it.
But if you just put in Hamburg statistics, it's a wildly famous book in its time. And statistics sort of like don't get old.
Right.
So all these fundamentals that you need to know,
they're there.
He did such a beautiful, beautiful job of it.
Okay, great. All right, so you alluded to decision science, and I think it might be good to spend a little bit of time talking about the difference between data science and decision science.
Right. And this is fuzzy. So because this, data science is sort of this new term, and it's very elastic. Decision science, on the other hand, is very well defined. Like I say, a lot of business schools, and if you're in an engineering school, the industrial operations or IOE department, you can't get through that thing without taking a class in decision science.
Okay.
And so there they walk through and they look at what classes and problems are you trying to solve, and they have all of these toolkits.
Right.
That are things that can be used. And what that class is about is like after you've done your math and your Diffie-Qs and stuff, for calc for engineers, then you walk through the different options, and it's really in an engineering sense. Pick up the right tool. Is it a flathead? Is it a Phillips screwdriver? Yeah. And Hamburg's book does it as well. And in the cover it says, here's a tool. Yeah. Here's all the assumptions that you have to make. And then use the right one. So here's an example. If you turn on most financial news networks today, you will see them talking about correlations between U.S. 10-year Treasury bond and gold, or the S&P 500 or something. Right. And they'll throw up a chart, and the chart will have wavy lines. Yeah. Right? Those wavy lines mean it's a non-linear function. And yet you look at people who are running those correlations, and they're using something called a Pearson product moment correlation coefficient. Okay. Which if you open up Hamburg's book, it says this can only be run on linear data.
Everyone pick up the book.
And then even in Microsoft land, if you're just doing charts in Excel land, right? Yeah. And I guess that's okay, Microsoft owns LinkedIn. You can click, and when you're doing your graphing and your curve fitting, right, you can pick linear or you can pick non-linear, right? So it's right click, pick a different,
and edit,
right? And so pick something that better reflects the actual way the data work. And now, of course, when you get to unsupervised machine learning, that's where you get to these torturing the data, right? Where you're using quadratic functions, and you're looping the quadratic to capture one data point.
Yes.
And you get into all of your problems of overfitting and all that kind of stuff, right? So you can go off the deep end in either direction. Yeah. And that's what you need to be aware of. But for those of you that are out there in machine learning and you're trying to perturb your unsupervised models, remember most perturbation methods aren't looking at cause.
Right.
Which is why all these things you do, you're sort of getting it wrong all the time because you lack the causal information to sit back and say, is this data point relevant? Is it not? Why is it there? What is it doing?
So there's just a gap in understanding of what you can use with which algorithm, right? That's the limitation of machine learning in this process. I was just going to ask, are there any other limitations in using machine learning and all these advanced techniques other than just not knowing which algorithm to apply to which situation?
Yeah, I mean, we talk about it in terms of animals, right? I mean,
animals, for those tuning in, we're talking about animals now.
Now we're talking about animals, right?
From feet to animals, yes.
And this isn't new, but it's just a simple way to explain it to those business people or wear ties that are too stuffy to know, right? So when you're dealing with supervised machine learning, right, everything's got to be tagged. You got to know what good looks like.
Yeah.
Right, and so it's the classic problem of internet kittens, right? Which is back to this issue of job descriptions. We're asking for PhDs in job descriptions. Well, a PhD project, 3 years ago was a high school project now with downloadable code from GitHub, right?
Yes.
So the issue is, how do we know what it looks like? Or another animal, the classic wolf dog problem that came up that looks at the bias in the data, right? Why were the huskies being classified as wolves instead of dogs? And it wasn't because of some facial features that everybody was guessing. It's because the huskies were photographed on snowy backgrounds. And so the algo is associating snow with wolf. Right? Now when we switch over to unsupervised machine learning now, we're just doing pattern matching. The classic explanation there, I happen to use butterflies lately, but you can use whatever you want. That's only because I got a child sorting toy online, and it was butterflies. And these are for like 1-year-olds. And you've got butterflies that are different.
Wait, why did you get that toy? Were you bored or?
Oh yeah.
To play with it?
It was watching my kids watch it. They have one with baby dolls.
Yeah.
But some have different wing shapes, different butterfly designs. They're different colors, different sizes.
Yeah.
And the thing is that the kids can sit back and sort them, right? All the same color, all the wing positions are the same. My kids had baby dolls, so they're holding spoons or not holding spoons, all this kind of stuff. And there, the situation is the algo has no idea of knowing which one is better than another. Whereas a 1-year-old makes some intuitive decision that say they want color or they want size or anything else, right? And so without having that business context of understanding what is relevant in a particular circumstance, right? These things are not as smart as a 1-year-old. So you always have to tear down the math and understand what are the limitations, because every mathematical equation, right down to a simple average, by definition includes and excludes something. And when you exclude, you're saying it's not important and that condition will not change over time. And you take a little butterfly, a little caterpillar, like Hermie the butterfly, and it grows, right? And it's same creature, but it's metamorphized. And now it's something different. And so these are the kinds of things that we've got great difficulty handling, and where you can add more business value if you understand what the business is, what the challenges are, what the questions are, and then how to plug the data into that. And of course, there's the behavioral aspect too that comes in for decision science.
Right. So since you have recommended so many books, Anil is asking for a book recommendation on cybersecurity metrics. Any books come to mind in cybersecurity in this space? Articles, books, people, anything? Resources?
Well, I wrote the Operational Risk Handbook.
Operational Risk Handbook by Barnier. Awesome.
And there's a chapter on IT risk that applies operational risk metrics down to it. The same thing we've been talking about with systems analysis is what underlies this. So much of cybersecurity metrics, the core problem is that they were built on COSO for small business from 2005, which was really designed around how do we audit small businesses and how do we ensure accuracy in financial statements for small businesses. That was got put together with some work from the Europeans who were applying Napoleonic code, and that led to the whole control-based regime that we got, especially out of the Basel banking regulators. This is completely different than the whole systems school of managing risk. So again, doing the network optimization, the bandwidth, everything that's going on in your IT department except security is based on systems methods.
Okay.
So the premise of the Operational Risk Handbook, I bring in systems methods, largely relying on W. Edwards Deming, the great quality guru, leadership, whatever.
Quality
he created
control
total quality management.
Yeah.
And that that is the big difference. So anything you're doing in cybersecurity, including AML and applications of machine learning to that, use systems methods. Do not use control methods. And again, the Ethiopia Lion Air, all these other crashes are examples of where in other disciplines, controls are known to kill people.
Right.
Because as soon as you exceed a boundary, a systems
Red
limit.
flag.
Red
Goes
flag,
up,
right? It's
Yep.
like the little bubbles on your Microsoft brand screen that bounce around. The bubble is happy as a clam until it bounces into another bubble, and then all bets are off.
Yes.
It has reached a system limit, right?
Yeah.
And so that's the problem that control-based approaches break in. It's like putting sticky notes up on a wall or pin the tail on the donkey.
Yeah.
It's not looking at how things actually behave end-to-end in a dynamic world.
Mm-hmm.
So that's what I did in the Operational Risk Handbook, and there's other books that are sort of anything with a systems flavor, especially those that come out of sort of a military kind of approach,
Okay.
are going to use systems methods. Those that come out of an accounting and auditory approach are going to use controls-based methods.
Okay, interesting. Thank you for that. So I know we touched on data visualization a bit, but I did want to ask you kind of what role do you see data visualization playing in the whole process of answering business questions? And kind of part B of the question is, what can go wrong? Let's say your data analyst puts a chart in front of a business decision maker. What are some of the issues that can arise at that point?
Yeah, I mean, it's a great question because it's sort of a classic. I mean, Mark Twain and all these others have talked about, lies, damn lies, and right?
Statistics and lies.
Yeah, and so just think of some of the basic things you were taught. Again, Morse Hamburg, right?
Mm-hmm.
So if you take a chart and you have an origin point other than 0, right, you're now distorting the view, right?
Yes.
But the thing is, if you've got an origin point of 0, well, your variations look really small.
That's
right?
true as well, yeah.
So now you've got to sit back and say, well, how do I not lie with this chart? And an honest
Yeah.
statistician will sit back and say, well, let me put the chart at origin and go to 600 on each axis, vertical and horizontal, right? And say, here's the big pattern.
Mm-hmm.
But now let me zoom in on this feature of interest.
Okay.
Right? So you've not
So then you can see
distorted
the
the person,
variation better,
right?
right.
Because otherwise you put, and again, the financial news is horrible, right? They'll zoom in,
Yeah, I know.
they'll say, it's a horrible day, it's going
Huge
like this.
jump, and then when you zoom
But if-
out, it's like
Right,
a
right. But
straight
if
line.
you look at the day before, it's tiny, right?
Yes.
So that's the issue, that you've got to be an honest broker,
Right.
right? Part of that is just anything that applies to statistics and visualization you can be an honest broker with, but part of it also applies to understanding the business context.
Right.
And this is where it's sort of a recursive kind of problem, and back to your expertise in data storytelling, Kate, because here you frame the issue, right, with that journey in the life and said,
Right.
this is what we're trying to explore. And this is, again, classic market research from the 1950s and 60s. Think Ford and cars and the work that McNamara did, Robert McNamara did as president of Ford, right? Because he was a data geek from MIT.
Right.
Right? So now you come in and you say, how do we frame this issue of somebody wanting to be in a car and what do they want to do? And you end up with a Ford Mustang,
Yeah.
right? And then, but on the other hand, he was the guy that put seatbelts in cars because it was a packaging problem, right? Because they were looking at crash statistics and why people are dying and the injuries they're suffering and being impaled on steering wheels,
Right.
so they made breakaway steering wheels, right? All these things came from data analytics, but it was only because of that recursive understanding of problem, data, problem, right? And they did not have a gazillion records from the Centers for Disease Control, right?
Right.
But they took what they had and they did all these things that dramatically reduced highway deaths.
So just start with what you have. Don't have to wait years
Right.
to collect
Right.
tons and tons of data.
And in the understanding, that's where we get data context, or the big word, data contextualization, right? So.
All right, well, Brian, this has been awesome. I think, I learned a lot. I think people really got value out of this session. So I thank you for joining me here today on LinkedIn Live. And anything else you want to say, any last words before we end the session?
I just hope, like this with my students, that this empowers people, right? Because if you're out there that came in as a software engineer, a mathematician, and you're trying to go, is there more to my career than data cleaning? The answer is yes, absolutely, positively. You can solve these big things like Disaster AI does, like the Blue Sky folks do, like others that I'm working with are putting visual programming languages on top of R and Python. So many of these, you can do this. It's available. There's decades of stuff that you can read and learn, and I just hope you have a lot of fun doing it, and I look forward to seeing the impact that you're going to make in the world. And Kate, thanks for putting all this together.
Yes, thank you again, and we'll see you next week. Thank you. Bye.